And as telecom operators transition towards Open RAN architectures, achieving optimized network performance, energy efficiency, and seamless interoperability that among multi-vendor solutions remains a key challenge. This panel will talk to leaders from Samsung Networks, Vodafone, AMD, and also Rakuten Symphony to explore how Open RAN innovations maybe enhance network efficiency while driving sustainability and cost effectiveness. And gentlemen, welcome to the program.
Hey, thank you.
Thanks for being here. I know we're first session this morning. Everyone's bright and early, so we appreciate everyone being on time. Muslim, I want to start with you. Certainly the title of the session is Open RAN for Optimized Performance, Energy Efficiency, and Interoperability. I want to start with energy efficiency. Talk about that relationship to Open RAN.
Absolutely. So Open RAN, the RAN is the scarce resource of the network. So you have to really be very precise on resource usage. You have to be dynamic in adapting on resource consumption. So for example, you can use AI to really determine how to scale down and up the power just to match the needs of the network. And that's why this is one mechanism you can have there. Dynamic power scaling, very important. Also you can have, let's say, predictive behavior and learning, which helps you to understand the patterns and also to go with the flow because dynamics are changing. If you can pre-adapt to them in advance, then you can be more efficient in your Open RAN. And also you have things like, for example, in networks, classically, the RAN part consumes maybe 80% of the overall power. So you can think of integrating renewables, you can think of being more efficient in the basic way of energy generation and consumption. So there are several things here, but most importantly, scaling, dynamic adaptation, and predictability. And that's where we start from.
Kumaran, drivers for energy efficiency and Open RAN?
Yeah, no, that's a good point. That was a very good introduction and overview. I think from our standpoint and looking at what ORAN's really about, it's leveraging server technology, right? So fundamentally, you're looking at how servers deliver power efficiency. And really, if you think about the fundamentals for servers, it's about providing more cores and providing higher performance per core every generation within the same power envelope. So you can take advantage of that, leverage that with Open RAN, right? So that you get the cadence, you get the consistent power efficiency gains every 18 to 24 months. You have the next generation, kind of the Moore's law type of effect. So that's an important benefit that comes along with the ORAN architecture, right? Mm-hmm. The ORAN technology, right? And then you have the implementation as we talked about. So there you can have power scaling, you can have lots of features. We use this chiplet technology that allows you to scale power very efficiently across the architecture. Then also between the CU-DU split, you can pick components that are optimized for the DU versus things that are more throughput oriented for the CU, right? So the different core counts, different type of CPUs, different server technologies that can be deployed to achieve this.
Anshul, drivers for energy efficiency?
Yeah, I think I totally agree with Kumaran, by the way. Like at Rakuten also, when we started our journey like a few years ago now, we looked at ORAN as a domain. So not just like the radios or the CUDs, like he rightly mentioned, the servers and the compute part of it. So there are essentially a lot of levers to, play around with and optimize at every level. Like, Kumaran was mentioning, even the server compute, managing the clock cycle, clock speeds according to the workload so that, you can optimize the energy consumptions. But also adding on top of what these guys just mentioned, for the enterprises too, sustainability is a big topic, and what we are now trying to achieve is sort of offer a green slice kind of a use case where you have a chunk of network or a slice of network for a particular enterprise, but they also want to reduce the carbon footprint. So we have come up with this new concept of green network slicing or green slice, which also looks at energy efficiency in a different paradigm when it comes to enterprises and sustainability use cases.
That's fantastic. That is a really cool use case. It just shows you the power of the ORAN architecture, right? You couldn't do that with traditional RAN, but the fact that you have the ability to slice, you can then pick what is the best power efficient model, and then you can sell that as a service.
As a service, yeah, exactly.
That's fantastic.
We are trying these things out in Japan, of course, but also elsewhere. So that's we have been hearing similar feedback.
Daniel, I want to go to you, sort of the next frontier, if you will, for optimizing energy efficiency for Open RAN. That's AI and machine learning. I'm going to go all the way down the line here and get everyone's comment. Start with you, Daniel. Where are we on that right now?
So actually, if you think about it, AI works better in data center-like environments, and that's what software-based networks do. So basically, you have servers and uniform software running on them. So this is very important to apply AI. And one of the tools that we have, that we are offering, that are most powerful in this sense is the Energy Savings Manager, which basically is analyzing data traffic patterns per cell level. So we can optimize down to the site. This is adding a lot of granularity to the optimization that you can do in terms of energy consumption and other topics as well. We also have another very interesting development, which is the Energy Savings Insights that applies digital twin technology. So basically, we are helping operators to create a digital replica of their network and then experiment there what things they can do to optimize energy. So they can basically see what works and what doesn't before they deploy these solutions. So all in all, ORAN is a very good way to increase the energy efficiency of networks.
Yeah, I can just acknowledge what Daniel said, and also, for example, in the ORAN, what you can do when you have multiple coverage of operators in a certain RAN area, you can do granular, which is a very good keyword here, granularity in terms of switching on and off radio modules and to cover up for the other party. So you can have an area covered by 2 operators or 3. One can take over if you have the overall traffic covered, and then you can save a lot of power switching off modules for intervals taking over. We had a project where we call this on-guard tour. So you take the on-guard tour for other operators, and if you can predict traffic patterns, you can really distribute the turn in who takes over the RAN part. You can do very optimal granular on-off switching and save a lot of power. As I said, it's about RAN is just about 80% of the overall power consumption. So there are things like this, and also, of course, I mean, there's an overhead when you do optimization, analytics, AI. It has to be really smaller than the benefit you get out of it. So when we talk about energy efficiency, you need to measure in a, let's say, tangible way what is the real benefit or saving that you have there. And then you have to really see if the overhead to get there is really smaller. And then there is one important point, last one to add here. It's about also fairness and monetization. For example, if you, let's say, take turns as operators to cover up for the overall traffic, how do you really incentivize the ones who do more? So there is a necessity to develop business models further, where you distribute the benefit and the load of work. And this is still not yet matured enough. It's still in the pilot phase.
Yeah, that's all really, really good points. So one important thing to remember, when we think about AI, or we hear AI these days, we automatically think like high-powered GPUs, and you heard about nuclear power plants being built. But we're really talking about here for ORAN is traditional, more like MLPs, like more, kind of models that aren't as, they're not generative AI, for example, right? So it's really about optimizing the links, optimizing the power states. That we can do within CPUs very, very efficiently. And to your point, you always have to get the gain versus the amount of energy you're spending on the AI itself. We think that's actually very, very plausible. And we can do it within CPUs, and scale up and scale down, turn off the AI CPUs when you're not using them, but collect the right data so that you're able to go, appropriately turn it, put it on when you need it. In our architecture, we actually do have, potentially a lot of cores, and some cores customers are actually dedicating to AI functionality, right? So just standard CPUs, but just certain cores that they will turn on and turn off as they turn on and do analysis on AI or run the AI algorithms. In the DU, in the actual ORAN station.
Yeah, I think I agree with some of these points. Like, AI definitely helps us bring in more granularity as well as the proactive approach instead of, a reactive one. Also, one more point I would like to add on, particularly on the contribution of AI, is, like the industry is typically used to having these, KPIs, like the term called KPIs, which is essentially like combination of certain counters that certain humans decided in a lab and called it a KPI. But I think with AI, since we have now a system which can understand, we don't even look at any KPIs. We just take in raw counters and let AI tell us that what should be the right KPI or what should be the right thresholds. So instead of moving, instead of having like a human-based KPIs defined to measure some certain stuff, we can just have AI recommend us what we need to measure, what we need to look at, and it can even predict with certain confidence beforehand, where we can take some actions instead of like just having certain rule-based policies. So I think that's where the AI is playing a big role in even taking us a level further into some of these energy efficiency algorithms.
That's a very important point, actually, because when you optimize for energy efficiency, there is a trade-off, which is network performance, right? So you need to make sure that network performance remains the same while you are applying this mechanism, and this AI is allowing to do that. For example, we did some real-life deployment with Verizon in the US, testing this energy savings manager that I mentioned before, and basically what we saw is that on average we were achieving 15% gains in energy efficiency while maintaining the network performance, which is a key topic as well.
Just to add to what my fellow panelists said, it's very important indeed that AI, it's first of all to really find optimal policy based on dynamics in the system. And then, because it's mainly put in the RIC, in the RAN intelligent controller, and then how to enforce the policy is also with AI through automation. So you have AI playing a role in shaping the policy, determining it, and applying it. And that's why it plays a double role, which is quite critical to achieve this performance increment that you have there.
So that's something we've seen in multiple applications where humans break down after a few different parameters, your heuristics that you could come up with are, mentally saying, okay, this should be powered down when this state is true. It isn't always obvious what matters in a real network, right? So if you can take hundreds of parameters, run them through a model, that's not something a human can normally do, but an AI can actually, an AI model can do very, very effectively. And so you get these gains that you wouldn't otherwise see. Predictive failures, all these type of things really are based off of many, many more parameters than are humanly comprehensible, right?
Yeah. Muslim, I want to talk about the ORAN Alliance and its support for interoperability, which is part of the discussion today. But before I do that, Kumaran, what is the role of accelerators for Open RAN, just really quick?
Oh, yeah. So with Open RAN, obviously we're leveraging a lot of server technology. It's also possible, in fact, a lot of implementations today have acceleration as part of the server, and part of the implementation, which is perfectly fine. In fact, that's sort of the way that the business has sort of evolved and started. Our view, I think, we support both acceleration and software only. Our vision, though, is that over time, what happens is that the servers are on that 18 to 24 month cadence where they're continuously getting better. So there should be an intersection point where the acceleration gives you a certain bump, but the software only keeps getting better and better. So there should be our view is there should be a point where the servers actually get to the point where it is fundamentally good enough, and that is really what the original vision of ORAN was, right? Is to have that. That capability in an intersection. Fundamentally, nothing wrong with acceleration. The other challenge you have 18 to 24 months where you put out servers. You have to also keep refreshing the accelerators at that same pace. That actually becomes very economically challenging. That's one of the things that we've seen, as a challenge to deployment with accelerators. They don't keep up with the cadence of the server CPUs.
Yeah, at Samsung we have to work, of course, with accelerators and software-based, but this is a great trend that we're seeing. So this is the right thing to do in the basically path to have multi-purpose platforms, servers in the network, and make the network like a data center, where you can run AI, different workloads, as well as the network applications.
Back to you, Muslim. Interoperability, ORAN Alliance, and how they're lending support.
Yeah, absolutely. So ORAN Alliance is a facilitator of many different aspects, and there are already some tangible results there. So you have certain APIs that enable, let's say, exchange of assets and functionalities. You have interfaces that are standardized for inter-vendor exchange of, let's say, functionality and resources. You have interfaces like E2, A1, R1, O1, and there are several where you can really interoperate tangibly together. And also there is the, let's say, working within the ORAN Alliance, it's a bit like other standards development organizations that you are able to have in a democratized way reach a consensus of collaboration between stakeholders, because even ORAN, it's crucial that vendors and vendors collaborate, but also vendors with operators and all other ecosystem players. And that's a good environment where these things are going forward, maybe at a slow pace, because it's a bit over-democratized. But these are the three key, let's say, lanes where this thing is coming to shape. Yeah.
Daniel, I want to go to you on maybe lessons learned for Open RAN interoperability.
Yes, I think Muslim made a very good point about over-democratization. Actually, I mean, interface specifications are super important, and it makes the industry work. But you have to collaborate many different parties, including the operator and the vendors. And for that, you need to have a very strong collaboration, which requires some processes, governance, frameworks. And by the way, Vodafone is doing a very good job there in creating frameworks to manage the Open RAN vendors. This is very important, so everyone knows what they are expected to do across the life cycle of the network, and have absolute clarity and be very well aligned. So there are different things that you should take into consideration while doing this. One thing, in our view, is choose the right partners, because Open RAN vendors aren't just offering the right technology, but they also need to know how to work in these multi-vendor environments with the right support and the right expertise. Also, I mean, there is the important role of the system integration. So having a prime vendor can be an important success factor if you choose the vendor right, in order to apply Open RAN to your network. And for operators who don't want to do all these coordination activities, etc., there is also the option to buy pre-integrated, pre-validated solutions that we also do, because we have a very rich ecosystem partner that we can use to do this.
Interesting. Anshul?
Yeah, sure. I think I agree with Daniel and Muslim. I think technology is there, the standards are there, but what important is also like the over-democratization. To prevent that, it's important to have a process when it comes to integration. So what we did in Rakuten Mobile, a few years ago, and we are following that in Symphony too, is to have a proper integration with vendor lab to, your own operator lab, whereby all vendors, the entire CI/CD from their lab to the operator lab is, like a one pipeline, and a lot of aspects. Since there are multiple vendors involved, there are a lot of interdependencies too when it comes to lifecycle management. For example, if you have a new version of a CU, you might need some upgrades over the servers or the accelerators as well. So how do you manage that lifecycle as a process? So I would say technology is right there, but a solid process implementation complemented by a like a CI/CD kind of a framework is very important when it comes to interoperability, and to do it at scale without falling in the trap of over-democratization, as Daniel just mentioned.
Yeah, actually, Anshul, I wanted to ask you about maybe some milestones we need to reach in order to reach this commercialized, large-scale Open RAN deployments. You sort of touched on a couple, but do you want to add anything?
Yeah, sure. So I think our belief is that in order to truly leverage the benefits of Open RAN, it's also important to take into account the SMO, RIC, and the efficiency that Open RAN principles bring in terms of like certain milestones I could think of that we had in our mind. We started our rollout in Japan was to have like a solid zero-touch provisioning kind of a process. It not only helps you to deploy your network faster, but also in a day 2 scenario, things like upgrades, auto healing, scaling, and things like that. So unless you have a solid digital, foundation with the right inventory, with the right, digitalization of the entire provisioning flow, such as ZTP, is important. And when we say ORAN, I mean the entire ORAN domain that consists of compute, some radios, the RAN software itself. So I think having the ZTP, the auto acceptance processes, some of the analytics, and the framework to have the right RAPs. When I say RAPs, all across day 0, day 1, day 2. So I think it's important to have the framework ready and do the deployment in the right manner in order to make sure that even in day 2, you don't get overburdened by the complexity of integrations. So having this digitalization framework and automation framework from day 1 is very important in order to truly scale, and that could be a good milestone for everyone before going to production.
Yeah. Just listening to you, it occurs to me how much you're leveraging data center standard practices in this deployment model. I mean, it's really powerful.
Yeah, it's a new world for telco, especially like how a hyperscaler would manage their infrastructure, their applications is something that is absolutely essential when it comes to Open RAN adoption and scaling.
Kumaran, milestones from AMD's perspective as far as these maybe impending large-scale Open RAN deployments. Anything coming
Yeah,
along?
I mean, I think for us, getting the hardware platforms, making sure that we're, get the NEBS compliance in the right form factor, the right power. We've been working with a number of partners, number of our OEM partners to go enable, the right platforms, the right interfaces. All of those pieces, are super, critical from our point of view because we're a hardware vendor. Sure. But I think this unsung hero is really here in terms of being able to develop these layered architectures. A lot of what we talked about earlier in terms of the power savings, the power management, the AI applicability, that all comes because of these the points at which you've defined these interfaces, such that you can not only have interoperability between different vendors, but also insert AI in a point where it works across multiple different components, right? I mean the CUDU, as an example, right? That break allows you to have visibility across all these different nodes. Yeah.
And actually, this is all great, and I fully agree. One issue I still see here is that which we need to overcome is the business model monetization. So AI upgrade is an upfront invest, chips upgrade, business model upgrade. But then, where are the customers that are really willing to pay for this benefit, if you can generate one, and who will cover your investment in the technology part that is really, let's say, not generating the same amount of revenue that you put in. So that's why there's still a challenge. It's faced by all operators, vendors. Operators have maybe a bit more pressure, but there's also the part: how do you monetize? How do you do the ROI on this? And to really let it take traction from the business perspective, something that I think about sometimes.
Daniel.
Yeah, I mean, in terms of important milestones coming up, I think that there are a couple of them. My personal maybe milestones. So I'm based here in Europe, and I would like to see more announcements for Open RAN deployments. We have a lot of traction in Asia, Japan, in the US, but here in Europe it's a little bit slower. So we would really like to see that. Maybe in the next 12 months it will be really nice to see some big announcements coming up. And another thing is to make automation and AI integration real and make it in the real networks right now, in order to make Open RAN more cost effective, or much more cost effective, and much easier to manage than traditional RAN. And then is when we will see Open RAN really taking up.
Well, that's an important point with respect to the ROI. I mean, part of what you're going to get is the benefit of the utilization of server technologies, right? Of standard data center technologies. If you're able to leverage those and then, make that, reduce your costs, and then you make it profitable, right? That's, I think, the key. Once we figure that out, it'll make ORAN deployments more efficient, less costly, and more profitable for the vendors participating.
It's a slow curve, but it's gonna get there.
It's get there, yeah. That's right.
Yep.
Yeah, I think a lot of the discussion here at this event, certainly in the AI space, but also in the Open RAN space as well. By the way, when you're talking about Europe and the proliferation of Open RAN maybe being slower than other regions, are you talking about regulation? What's causing that?
Well, I think regulation is getting there with the DNA. So we see some good traction for Open RAN, and also adoption by operators of the technology.
Okay. Fair enough. Anshul, thank you very much for joining this discussion, by the way.
Thank you so much, having me. Happy to be here, and very fruitful discussion, I guess. We got some real practical insights, I guess, on energy efficiency and AI.
Yeah, we appreciate it. Kumaran, always good to have you.
Thank you.
And we
very
thank
much for
AMD
inviting
for
me.
supporting the session, by the way.
No.
Thank you
You're
very
welcome.
much.
Thank you.
Muslim, as always.
Always a pleasure. Thanks
Giving us your time. We appreciate that. And Daniel, very nice to meet you.
Nice to meet you too.
We
Thank you very
have
much.
the same next iteration of this discussion this time next year.
Okay.
So we all make it.
Thanks very much.
Okay.
Excellent.
Looking forward to that.
All right.
Yes,
great
looking forward to
discussion.
it.
Thank you all.
Thank you.
Thank you.